Students, this is Naresh Bemorku, HOD of Data Science in Hierarchical College. Today I want to explain you about hierarchical clustering in machine learning and how it will work. So first of all, the hierarchical clustering, it is an example for unsupervised machine learning algorithm and which is mainly used to group the unlabeled datasets into clusters. So what is meant by unlabeled dataset means, so which is having only the input data, we are unpaired the input data with any type of output data. And it is also known as the hierarchical clustering analysis. In hierarchical clustering analysis, we are mainly going to develop a hierarchy of clusters in the form of a tree structure, and the tree structure we call as a dendrogram tree. And we can able to implement the hierarchical clustering analysis in two techniques, two approaches. One is agglomerative approach and second one is diffusive approach. And within the agglomerative approach, it is also known as the bottom up approach. In this algorithm, we are going to be start with all the data points as the separate clusters, and after that it is going to be combined the closest clusters into a single cluster, and it will be repeated until all the data points will be created as a single cluster. And another approach for the hierarchical clustering analysis is a divisive approach, and it is also called as the top-down approach and a reverse approach to the agglomerative approach. So in which initially it treats all the data points as a single cluster, and based on some criteria, it is going to be divide the clusters into multiple clusters. So it is called as the divisive approach. And in this video, we are going to be know about how the hierarchical clustering approach will be applied for agglomerative approach. Coming to the agglomerative clustering technique. So for explaining this technique, I am taking an example with 6 data points, and each data point will be treated as a separate cluster within the first step of agglomerative hierarchical clustering. So if you are having the 6 data points here, you are having 6 number of clusters. So within the next step, it is going to be identify the closest data points, and it is going to merge those two data points as a single cluster. So the number of clusters will be reduced to n-1 here. And after the next step, it is going to identify another 2 more closest clusters and merge them together to form a cluster. So the number of clusters will be reduced to n-2 here. So the same process will be repeated until a big cluster will be formed. So here, if you observe this one, it is the number of clusters will be reduced to n-3 here, and it is n-4, and it is n-5. So finally, we are getting a big cluster as a result. And after forming a big cluster, it needs to develop a dendrogram tree to divide the clusters as per the problem. So how to create a dendrogram tree? It is the one we need to discuss now. But before that one, how the clusters will be formed. So why we need to choose these two data points for making as a single cluster, we have to know. So for that one, it is going to be used some measures for the distance between, for calculating the distance between two clusters, and those methods we call as linkage methods. So we call them as linkage methods. So what are the different linkage methods? So to find out the closest distance between two clusters, so we are having different types of linkage methods. In that one, the first method is a single linkage method. So it is the distance between the shortest distance between the closest points of the clusters. So if you observe these two clusters here, and it is the closest point for this cluster, and it is the closest point for this cluster, and it is going to be find out the distance between these two things. So and it also find out the distance between this cluster to other clusters also, if you are having any other clusters. So it is going to be match the two clusters which are having the shortest distance between the closest points of the clusters. So it is called as a single linkage. And another one is the complete linkage. It is opposite to the shortest or single linkage here, and it is going to be find out the farthest distance between the two data points. And it is one of the popular linkage method because it forms the tighter cluster than the single linkage method. And another one is average linkage, so in which the distance between each pair of the data sets is added up and then divided by the total number of data sets to calculate the average distance between the two clusters. So it is also one of the popular linkage methods, so in which the average distance between each data point within the clusters will be calculated, and the clusters which are having the shortest average distance, those two clusters will be going to be merged here. And another one is the centroid linkage, so in which for each cluster the center points, the distance between the center points will be calculated here, and for those clusters the distance will be shortest, so those will be measured within this type of linkage method. So these are the different types of measurements used for finding the shortest distance between the two clusters. And after that we have to know about, after completion of merging all the clusters into single cluster, we have to know that how to create a dendrogram tree. So dendrogram tree is a tree like structure that is mainly used to store the each step as a memory in the hierarchical clustering algorithm. So in the dendrogram tree, we are having two axes. One is the y-axis, which shows the Euclidean distances between the data points. And the x-axis shows the data points of the given data set. For example, for our taken example, it is the dendrogram tree. If you are observing the left-hand side chart, so we are having totally 6 data points known as P1, P2, P3, P4, P5, and P6. And what are the steps we follow there? So initially P2 and P3 will be combined into a single cluster, so because these two are the closest points. And after that we are going to be combine the P2 P3 cluster to P1 here, so it is another cluster, a single cluster. So after that we are going to be combine P4, P5 and P6, and P5 P6 with P4. So finally we are going to be merge these two clusters as a single cluster. So it is the algorithm we follow for agglomerative. And from this one we are going to be construct a dendrogram tree like this here. So if you observe the dendrogram tree, so P2 P3 data points will be combined here, and after that P2 P3 cluster will be combined with P1 and P2 P3. So it is the second cluster. And after that P5 P6 will be combined as a single cluster, and P4 P5 P6 will be combined as a single cluster. So totally we are having two clusters here. This is the one cluster and this is the one cluster. And finally we are going to be merge these two clusters as a single cluster. So finally we are having this one as our dendrogram tree. And the height of the dendrogram tree represents the distance between these two clusters here. So this is the dendrogram tree. Like this, the hierarchical clustering algorithm is going to be combine the similar data sets into clusters. So thank you.